Imagine looking up at the night sky and seeing something impossible. There are two moons. One is our familiar moon, shining above Earth. Beside it is another enormous world, following Earth through space. The first question is, how massive is the second moon, and where is it orbiting? Those details would determine everything. The exact outcome would depend on mass, distance, and orbital geometry, rather than simply adding another light. If the second moon were small and far away, Earth might experience only modest changes. But if it were similar in size to our moon and orbited relatively close to Earth, the consequences could become dramatic. The biggest immediate effect would be gravity. Our moon already pulls on Earth's oceans, creating tides. A second moon would add another gravitational pull. Depending on its position, the two moons could sometimes strengthen each other's tidal effects. Coastal regions could experience higher tides and more complicated tidal cycles. At other times, the gravitational pulls could partially oppose each other, producing smaller tides. The oceans would not simply rise permanently. Tides are constantly changing as Earth rotates and the moons move through their orbits. The second moon could also affect Earth's rotation. Our existing moon slowly transfers rotational energy from Earth into the moon's orbit, causing Earth's rotation to slow very gradually. A second moon would introduce another gravitational interaction, potentially changing that process. But the biggest danger might be the two moons themselves. Two large moons orbiting the same planet would gravitationally interact with each other. If their orbits were poorly arranged, they could become unstable over long periods. One moon might be pushed into a different orbit. Another could move closer to Earth. In an extreme scenario, the moons could collide, break apart, or one could eventually escape Earth's gravitational influence. But scientists could imagine stable configurations too. A small second moon could orbit Earth safely if its distance and orbital path were suitable. In fact, Earth already has temporary natural companions called quasi-satellites and other small near-Earth objects, although they are nowhere near the size of our moon and do not behave like a true second moon. The night sky would also become spectacular. We could see two different lunar phases, two sets of moonrises and moonsets, and much brighter nights when both moons were full. Solar eclipses could become more frequent or more complicated, depending on the second moon's orbit. Animals could be affected too. Many species use the moon's light and tidal cycles to time feeding, migration, reproduction, or other behaviors. A second moon could disrupt those natural signals. Calendars based on lunar cycles would become more complicated. Nighttime landscapes would look different. Coastal communities would have to adapt to unfamiliar tidal patterns. Would Earth be destroyed? Probably not. A second moon would not automatically tear our planet apart. The real issue is orbital stability. If a second moon had a carefully chosen mass and orbit, Earth could potentially have two moons for a very long time. But if a giant second moon suddenly appeared close to our existing moon, their gravitational interaction could create a chaotic future. One could crash into the other. One could be thrown away. Or both could eventually end up on dramatically different paths. So imagine looking up tonight. The moon would no longer be alone. A second world would cross the sky beside it, changing tides, eclipses, calendars, animal behavior, and potentially the long-term evolution of Earth's orbital system. Two moons might look like a beautiful addition to our sky. But in space, beauty often comes with gravity. And gravity always has consequences.